Today, I will introduce the Rx characteristic sweep modular. First, open the modular. The first line of the top is the menu bar. The second line is the toolbar. The test point display area is right below the toolbar. Below the area is the test point setting area, which is used to set the parameters of each single test point. You can set the fault type of each test point here, including grounding fault, face-to-face fault, face-to-face grounding fault, and a three-phase fault. We set phase A grounding fault here. The end is used to set the terminal of the searching line. Angle end is to set the terminal of the direction. Z star is to set the beginning of the searching line. Phi star is to set the beginning of the searching direction. Z step is to use to define the size of each sweep. Current is to set the value of test current. Pmax is the maximum of the post-fault time. Inode is to set the value of node current. Power angle is to set the angle between voltage and the current. System frequency can be set in setting menu. Click parameter button, we can get into the global parameter setting page. This page is to set the common parameters of all the test points. We can set prepare time, perform time, post-fault time, PT position, and the CT polarity. We can define the boss side or line side, set according to the actual situation. With the PSS01 circuit breaker simulator, we can make circuit breaker simulation. Here we choose default setting. Fault mode can set the fault occur in a random VI angle or a fixed angle that you appointed. For example, you can set 180 degrees. Here we set as a random. We can add a DC offset. Test the model, we select the I constant. Grounding compensate factor has 3 types of expression, and the value is 0.67. There are 2 types of search mode. One is dichotomic and another is the linear. Dichotomic that means every time to choose the middle value of the searching scope to approaching, while linear is to approaching the result from the beginning to the end, only one direction. So, in most of the situation, dichotomic is quicker than linear. Set the rest of the parameters and click OK to save and exit. Open the binary setting page to set the binary input signal. In the assessment card, we can define the criterion to assessment our testing result. For Zone 1, the relay chip without time delay, and Zone 2 chip with 0.5 second delay. So for Zone 1, you can define as bigger than 0.001 second and smaller than 0.5 second. In the characteristic card, you can drop out the X characteristic curve manually according to the relay setting value, or you can just import the curve from our bank. For the experiment is a NARI 931 relay with forward cycle. Now, I will show you how to drop out the curve manually. Firstly, select the shapes. It's a cycle. Then, define the radius of the cycle according to the setting value of Zone 1. It's 2 ohm. And the impedance angle is 75 degrees without offset. You can set it as a reverse cycle simply by clicking the revert selection box. Here we have a forward cycle. Click OK, save and exit, and you can define any other shapes like this way. You can add Zone 2 by click Add button. Define the Zone 2 like the former way, and the only difference is the setting value is 4 ohm. You can also import the curve from our bank to avoid drawing it manually. Click Import button to enter into bank folder. It includes almost all the popular vendors. For example, we selected the cell 321 and the Rx characteristic curve has been imported into our software. It is extremely saved your time and effort. Okay, show time is over. Let's return to our NARI 931. Today, I will demo the Rx characteristic module on this relay. Okay, let's add some test points on the Z-plane. You can add one by one or once a batch. I prefer the second method, so click the Quick Add button to set the parameter. It's very simple. You just need to set the center and the radius of the cycle, the beginning and the end of the sweep angle, the search step, maximum fault time, and the fault model. That's all. After carefully check this point, just click F2 to start the test. It will search each direction by dichotomic method, and the result will display in result display area. If some of the test points didn't have a result, just select these points separately and do the test again after the whole test process. Finally, you will get all these results. The such task will be taken automatically, but it's time consuming. If you wanna get the result quickly, you can smaller your search range and larger your search step, but it will take the expense on your accuracy. Okay, it's finished. We get the zone 1 Rx boundary of the NARI 931. We can generate a test report. Choose the contents that you want from the report setting menu. A Word format report will be generated, including all the test records and data that you are concerned about. You can also save as a template file for the next time to do the same experiment. Here, we will go on to finish sweeping the zone 2 of the NARI 931. The most important in this experiment is the maximum fault time setting. Because the zone 2 has 0.5 second delay, so the maximum fault time setting must be larger than 0.5 second to avoid the zone 1 tripping, or the experiment will not gonna be success. All the things will go on like the experiment of zone 1. Now, you can handle on different types of relay with the power test Rx characteristic sweep module. That's all. Thanks for watching. Please subscribe my channel. See you.